Hello, I'm Christopher Lyle Simmons, and we're in the IBA Boot Camp. This is part 1 of 3. The video you're about to watch is me going over that review slideshow. I'm not the best at it, but at least it's a nice reference where you can hear someone talk about the slides. So if you're unfamiliar, watch the entire thing. If you're already pretty confident in most of the information, but there's a few things that you're unsure of, then sort of fast forward to that piece of information and just listen to what I have to say. Really, you should be well aware of everything that's in red. These are items that will most likely appear on your certification exam. Now there's about 30 slides total. On this one, part 1 of 3, I'm going to go through the first 10 or so. So kick back and enjoy the show. See you at the end. All right, the IBA review. Let's start off with URLs. URL, you can see here at the top that it's the full HTTP and the www and the CIW, all these pieces. The Hypertext Transfer Protocol is what we're going to be using right here. This can also be like FTP. There's different things that it can be at the beginning of this URL, but for web pages we use Hypertext Transfer Protocol. The host server is this part right here, and everybody assumes that that's some sort of protocol, but it's actually the name of the computer, the name of the server, and it doesn't always have to be www, though traditionally, if it's the server that holds the web pages, they'll label it www, but it can literally be like nothing.ciwcertified.com. And the name of the computer that you're accessing through Hypertext Transfer Protocol would be nothing, right? So it can be anything that you want right here. It's literally the name of the computer that you're accessing. CIW Certified is the domain name, and then of course the top level domain. You can see .com, .org, .net. If it's .com, it's for commercial uses, which means typically you pay for it. .org is organizations, typically nonprofits, and things like .net is network, .mil is military. All of those top level domain names are kind of like a zip code or the area code of a phone number, right? The area code of a phone number. So at the top where it would say, first we look inside .coms, then we look for the domain name, we look for CIW certified that's located inside the .coms, and then finally we find their actual computer. The computer is www, and then we're going to be accessing it using a rule, a hypertext transfer protocol, or protocol is another word for rule, and we'll all be talking the same language. This whole piece right here is the deep URL, because you can see that it's actually accessing, using hypertext transfer protocol, a PDF document or some sort of document that's nested inside the URL there. The domain name system. And what this basically is in the old days when you wanted to contact another computer using HTTP or Hypertext Transfer Protocol, you had to actually know the IP address, the individual address of each computer. Like for instance, the computer that I'm using right now has a specific IP address. It is not necessarily tied to the domain name system because I'm not typically a server. But some of the bigger computers, like if you imagine Instagram's main computer, it has an IP address. But you don't have to know this number in order to access it. Your internet service provider, your ISP, like AT&T or Comcast or whoever you're using, they typically have a computer called a domain name server, and when you access the internet using that service that you're using, the internet service provider, the ISP, they'll access their domain name server. So when you type in something like ciwcertified.com, it'll go to that computer and it'll look up the IP address. And as part of a network, that network is the domain name system. So let's say that you try to find mrsimmons.com and you go into your ISP. Your ISP is the computer that the internet service provider that you're using. You ask them, I need to find mrsimmons.com. And their domain name server, their computer that holds basically the address book or the phone book of all the IP addresses, doesn't know it. It'll call another DNS, domain name server, a domain name server, and say, hey, do you have the phone number? And typically they'll find it and they'll call the whole network, this whole system, until they find the IP address, and then it'll access that computer using the IP address. So DNS, domain name server, it's the phone book that accesses a URL and translates it to the IP address so that you can find it on the internet. Networks. There's really, there's 3 types of networks, but we're only talking about 2 here. If you work at a business and all the computers are connected together, and you can remote into one computer or the other, you don't need any passwords. As long as you're on the network, you're able to go back and forth inside the same building, let's say. That's called an intranet. It's computers that are in the same location that can share resources and information. An extranet is something different. It's not the internet. The internet is all the networks connected together, right? All these extranets and intranets and all those connected together, and they're connected using passwords. But an extranet's mostly for like customers who want to order something specific for a company. It's access using the internet, but the network itself is contained sort of within its own pipes and using their own passwords. Like when we're at school, we use an extranet. Even though our school itself is an intranet, it's all one system, we're able to access other schools and other parts of the school district using your username and password. Same with when you access it at home, like how you're accessing this right now. You're actually accessing it via an extranet. It's not for the public. Not everybody can get into my Google Classroom. You need to have a username and password. So to repeat, intranet, it's generally for people like employees, and it's all in the same building. Extranet, it's for customers that you give them a username and a password, and they don't have to be on site in order to access it. They can be from other buildings. That's why this shows other buildings. And then the internet is just the interconnected networks of basically all the networks in the world connected together, creating the internet. Proxy versus firewall. A firewall, inside user can surf web, outside cannot get inside local area network. So the best way to describe it is, you can see here in this diagram, right? This is everything that's protected inside the firewall. Everything at our school is inside a firewall, and we can connect back and forth with the computers internally, and we don't have to be going out onto the internet. Whoops. The computers will, in order to access computers outside of the firewall, use a proxy. So when you're at your school computer and you go to the internet, your IP address goes to this proxy server. And the proxy server, there's a proxy server located at our school, and the proxy server sends your request out to the internet. The internet is never directly connected to your school computer. It's protected behind a firewall so that other users can't get in without a username and password. But more importantly, there's no direct access to your IP address or your actual computer. The proxy server knows who you are, so when you ask for a bit of information, you want to go to BrainPop from your school computer, and that school computer connects out through the proxy to brainpop.com. BrainPop doesn't know which computer it's necessarily talking to. It just talks back to the proxy, and the proxy sends the information to you. So it's kind of a 2-layer of security. The proxy is the computer that is sort of a middleman, but the firewall is just a layer of protection that doesn't allow any traffic to go in or out, but mostly in, without username and password or authentication. Protocols are just rules, and there's a bunch of different rules, and that's so that all these different manufacturers, you have Mac, and you have Samsung for smartphones, and you have Chromebooks and IBMs and PCs, all these different machines, but they're all able to access the same type of information. It's because there's a set of rules that allows all these different manufacturers and operating systems and all this to communicate back and forth. And the real big ones that you need to know when we're talking about the internet is HTTP, FTP, and to a much lesser degree, NNTP. HTTP is the one that you know the most. That's when you're going to a website, right? It's all web pages. If it says HTTPS, the S stands for secured, which means it has encrypted information. People can't necessarily read the information as it's passing back and forth in little tiny packets on the internet. FTP is a little different. File Transfer Protocol is using the internet, and it's using the same system of packets, right? TCP/IP, Transfer Protocol, and Internet Protocol, the little use of packets that go back and forth to exchange information on the internet. But File Transfer Protocol is not web pages. That's when you're downloading music or downloading a file, or you're transferring, you're uploading big bits of information. And sometimes you'll see it on your internet. If you hit download or something, if you watch up there at the top at the URL, it'll change for a little bit and your screen might go white for a second. And if you notice, it'll say FTTP, or most likely FTPS, which is the secured one as well. It's encrypted information. And that's the real secret. NNTP is network news, and that's for aggregated news feeds and things like that. Typically, you don't use them. They're antiquated just because everything's really handled by HTTP. But for the certification, you may see it on there, and just know that it's network news. You don't really need to know any other details than that. HTTP, web pages. FTP, File Transfer Protocol. That's transferring big things, downloading movies or music. If there's ever an S behind, that means it's encrypted because it's secured, right? Encrypted means it's sent with code so other people can't read it. And NNTP, just news. Let's talk more about FTP. There's two things that you need to know, or three real big things that you need to know as far as commands on FTP. And these will be on the certification exam. And they're pretty intuitive. When you use an FTP client, usually it's FTPS, it's secured and encrypted. Open means to access information. Put means to upload. And get means to download. And when you're using an FTP client, it's a little different than your browser, than like Chrome or Safari or something. That's designed specifically for web pages. An FTP client is a separate program that you use specifically for business, not necessarily in education. So it would look kind of like a browser, and you would type in a URL, but then you have to kind of give it commands like open and whatever you're trying to open to be able to see. Get, download it. Put is when you're uploading it. I'm sure you get it. Web browser. Okay, no commands, graphic interface. It's what you're using to view this right now. It interprets for the people who took the Site Development Associate thing last year. It's everything that handles HTML. It interprets hypertext transfer, or HTML, hypertext markup language. Whoops. And typically it's anonymous. You can use a web browser with no username, or it's open to the public. It's not a big deal. And that's with FTP as well. When you're using a web browser, there's no commands. You just hit the upload button or download button for FTP stuff. And usually it goes white, like I was saying before. So FTP client, it's different than Chrome or Safari or Internet Explorer, whatever you're using. And you need to give commands: open, put, upload, get, download. If you're using a web browser, and I described what a web browser is, designed specifically for HTML, right? And using the protocol HTTP, Hypertext Transfer Protocol. But you can use it for FTP, but there's no commands, right? Just like it says here on the screen. Hang in there, we only have 3 more slides. Email. There's 2 kinds of email services, right? One is to send and one is to get. And the way I remember it's pretty easy. SMTP, Simple Mail Transfer Protocol, that's a set of rules to send email, but I remember it as send mail to people, right? It's Simple Mail Transfer Protocol, but I remember it as send mail to people, right? To download it or to sort of store it is either POP or IMAP. And right now we're using POP3. When you go onto your phone, you would typically see Post Office Protocol or POP Protocol. And that's how you would download information. You get your mail that goes to you. Now, almost everything is cloud-based, but things like your phone, if you notice, as soon as you send an email, it might not always get it right away. Sometimes there's a little bit of a delay. It depends on your push or pull, right? And that's when you're sending mail to people, it sends it right away, right? SMTP, send mail to people, sends it right away. But POP, sometimes it does it every minute or every 30 seconds. Most modern phones try to do it almost right away, but it's not instantaneous. It uses POP3 or IMAP. IMAP is the one that we typically use, like if you go and use Gmail. You can go anywhere you want in the world and go to gmail.com and then go and see it because it's using IMAP. It's storing it on the server. POP is when it sends it to your computer and it kind of removes it from there. So it's kind of messy. 3 things to connect. You need an IP address, a username, and a password. The internet protocol is what you need, but really the best way to know it is you need a computer that's using an authorized IP address. 2 more slides to go. Web 2.0. All right, so this is different. Now Web 1.0, to be honest, you weren't alive when it was around. Web 1.0 is just basically hypertext markup language without any images, without any connections. It's just text with hyperlinks that you click that takes you to more text. And it was how the internet really sort of began, was just information. It looked basically like giant Wikipedia pages without any of the pictures. And they started adding pictures at the end of 1.0. But 2.0 is when it really became interactive, right? Interactive means that it went beyond just looking at simple informational text and images. It really started using people as resources in order to function. And that's what all this stuff is right here. When we talk about Web 2.0, there's a bunch of information that you are going to be tested on in that certification, but it's pretty straightforward. The first one is crowdsourcing. Whoops, excuse me. The first one is crowdsourcing. So where they use a group of people for ideas. Like with something like Pandora, you probably don't know it, but how people can rate things, and when they're rated, they go up higher in a hit, right? The computer doesn't know if it's popular or not without people voting. So it's using people's votes in order for it to become more popular and to become higher up in ranking. It's when you like or dislike things. It's also kind of a different idea. Crowdsourcing is weird, but really what you need to know is there's a group of people for the ideas, right? Collective intelligence is different. That's when a bunch of people get together to solve a problem. You're not just upvoting or downvoting, right? This is like a bunch of people collaborating together in order to solve a problem using the internet. This is like when you guys are working on a project and you have multiple people on the project and you're all working on parts of it in order to make a complete whole. Collective intelligence is everybody working on the complete whole. But crowdsourcing is kind of like when we're trying to vote on who made the best project and everybody in the room gets to vote yes or no kind of thing. That's crowdsourcing. Grid computing, you just really need to know this word SETI, which is kind of weird. It's a bunch of computers connected together to increase the processing power. Imagine your smartphone and you need to do a really crazy math problem, and it would take an hour for your smartphone, because of the limit that it has, to be able to do all the mathematics in order to solve the problem. But imagine if you had 30 smartphones all lined up next to each other, and you're able to split that math problem into 30 parts. And instead of it taking 60 minutes to finish because you're using 30 computers, it only takes 2 minutes, right? That's what grid computing is. A bunch of computers connected together, all working on the same problem, but separated out. It's different than collective intelligence. That's using the human's mind through computers. Grid computing is all the computers working together on their own problem, using the processor inside the computer. Cloud computing is something a little different. It's hosted applications and services offered by a third party. To be honest, almost everything now is cloud computing. When you save your data, typically it goes up to the cloud. Very little information is being stored now on the actual hardware that we use. A Chromebook's a great example of that. There's almost nothing stored on that machine. When you're on your Chromebook at school, all of your files, all of the web, everything that you're doing is going through a proxy server out to a website. That's that cloud computing location. And the cloud computing location has the information for you. Nothing is stored on your computer. And when you save things, let's say, they save up in your G drive, which is a whole different location. Software as service, SaaS, or SaaS. Software as service, the best way to look at it as something that you would pay for every month. I use Apple Music as a SaaS, right? Some people, instead of downloading and using Adobe Photoshop, which is a very expensive piece of software, they use some cloud version of it and they pay money monthly to use the software as a service. And it's spectacular because they don't have to worry about making sure it's downloaded on their computer correctly or that it's updated or whatever. They're able to just log in and through the internet access it. If they drop their machine blows up, they just get another machine to access it through the cloud. It's good to go. Software as service. Last slide. Folksonomy. And that's tagging. It's the weirdest word to describe tagging. When you hashtag something, hashtag Simmons is awesome. That just means anytime someone's looking it up, they can find that little bit of tagged. And it's a little different than semantic, right? The use of folksonomy is the tagging of information. Semantic is something that's a little bit deeper. Semantic is sort of the organization of that tagged information. If we had hashtag Simmons is awesome, there could be some semantic information out there that's called awesome teachers at Krista, but it's not a hashtag, right? It's just sort of a contextual location. And that's what the semantic information is. When you make a web page, typically you put semantic information in, and it helps the web search engines really contextualize where your website fits in the web. It's a nuance. And the last 2 bits of Web 2.0, texting. That's called SMS, right? And that's on a smartphone. Short message service is what it's referred to. You don't both have to be online. Someone can have their phone off or whatever, and you could still text them. Instant messaging, or IMing, is a little different. IMing it's used a lot in business because you know it's instantaneous. The person definitely sees what you're doing right away because they're logged in and active in it. And the way you know that is through presencing. And a lot of social media websites use presencing. You can see who's actually on the site at any time because they're not in sort of incognito mode. They're actually putting themselves out there. They're presencing, saying, "Hey, I'm online and I'm able to be communicated with." So texting, SMS is you send it to them, but they don't have to be there. Instant messaging only exists if both people are online. You very rarely don't use IM with your smartphone. It's always done on computers, and it's something that's done as sort of an application. It's a separate app that's running as a window over here that you can be working on something and IMing with people at the same time. Wow, that is a lot of information. But take your time and go through it. It's easier to chunk it into 3 parts like this. So make sure that you're spending some time reviewing every single day as we lead up to the actual qualifier and certification exam. See you all tomorrow. Bye.